Welcome to the CAD lab in the department. So this lab facilitates the learning of students in many courses related to graphics, modeling of the parts, simulation. Number of softwares available which include SolidWorks 2018, AutoCAD, PTC Creo, ANSYS, COMSOL. Students do lot of projects using these software. This lab supports the students in various areas of CAD, CAM and robotics, and there are hardware available for doing reverse engineering of parts and running different type of mechanism and stress analysis.
Welcome to CAM Lab. We have this lab established since 2008. In this setup, we have workstations which are 32 in number. So students of first year UG programs and master's program, they make use of this lab. So this lab has got softwares which include Pro Engineer, Mastercam, SolidWorks, HSM Works, and other CAM simulators which are available for running the machines. Students can make use of these softwares and hardware to simulate their CAM programs. They validate those, and then we take the students to the machine shop where they run the actual program and make their parts, learn the CAM modeling, the parts after their reverse engineering, the parts from industry. They can be very well machined on aluminium and different metals. So we have state-of-the-art production machines and trainers which are a couple of in number, and we will take you to that other facility which exists in the central workshop where we have kept these high-end equipment.
Welcome to the central workshop. So, as the name suggests, this is central facility for the whole institute, whereby we people are catering almost all of the students of Thapar Institute of Engineering and Technology, Patiala. So, first we are catering second year students by providing them reasonable training over here, so that they should understand how the things are going to be manufactured in any kind of industry. So we are having CNC machines, we are having conventional machines, we are having welding facility, we are having foundry technology facility, and we are having cell testing facility over here. And beside that, we are undertaking some of the projects which relates to our central workshop. These are some of the conventional machines.
Welcome to the sand testing lab. This sand testing lab caters to UG and PG programs and associated with the casting process. This is our sand muller. This is our sand remmer. This is our clay washer. This is our core baking oven, which is used to bake the cores. This is a sheet shaker, which help us to find out or separate out the fine grains and coarse grain. This one is universal strength machine.
In this CNC lab, we have 7 vertical milling machines and 7 CNC lathe machines. Basically, these are trainers. Facing, turning, taper turning, external threading, okay? And before actual machining, they do simulation, and with the help of G code, IM code, they make a particular program for a particular job, and then they come here for a hands-on training on these machines. Different types of operations are done on this job: facing, taper turning, drilling, threading, like this. These are students' made projects. This is CAM lab. In this section, you can see there are big machines. These are production-based machine, and this is CNC lathe machine. You can see from this side, it has a big ATC and big chuck. This is precision surface grinder. And this is vertical milling center. This is also a production-based machine. And some student project is going on this machine.
This is robotic arm 5 axis Master RVM2.
In this simulation lab, by using this CNC train software, they can machine every part.
This is advanced metrology lab, and this lab is typically for the PG students and as well as for research students. This is a metallurgical microscope, and if we want to know the structure of any material, we can see through this metallurgical microscope. You can see this is the surface profilometer. So if you want to know the waviness and the surface roughness of any component or any material, this is the best surface profilometer by Taylor and Hobson. Then we have this spectrometer. So if you want to know the composition, the chemical composition, or even the different elements which are present in a material, we can see through this spectrometer. Then we have this micro hardness tester. This is the particular Mozo 3D printer, nowadays widely used in our advanced manufacturing techniques. And this based on the layer by layer technique. It's a kind of additive technique. And this is the CMM, which is coordinate measuring machine. Here we know exactly the geometry of the component. This is a very well equipped lab with the name of Advanced Metrology Lab.
Welcome to the Experiential Learning Center. We have a small mini workshop for catering to the development of Experiential Learning Center in this venue. You can see here we have got a new car jeep which is being converted into electrical vehicle. So students are working on it. This is a setup where we have got mechanical tooling basically for all fabrication which caters from physics to electronics, electrical, mechanical engineering. All students, whatever development we have in Experiential Learning Center is being developed over here. So we have couple of equipment. We have toolings available with us. The students are preparing some go-karts, electrical car which we have already tested and converted into electrical vehicles. So this is one of the student project for e-transportation. And some of the products are being manufactured like we have some development for robotic parts and some other electromechanical devices. So this is a venue where all this development takes place.
So we are going to show you the different equipment in this fluid machine labs. So turbines. So we have different type of turbines like Pelton turbines, Francis turbines, Kaplan turbines. So this is a Pelton turbine, and this is a Francis turbines. It's a reciprocating pump, and we have another pump. This is centrifugal. This is centrifugal. This is hydraulic ram experiments. And this is a new experiment we have established recently in this laboratory. This is a demonstration of cavitation.
So this is a heat transfer lab, and I welcome all of you in the lab of heat transfer. So this lab, in fact, that has been designed for BTech students, UD program, as well as for MTech PG program. So talking about the conduction heat transfer, this equipment is related to conduction heat transfer, where the student they can perform experiment on linear conduction, radial conduction, and they can also perform the experiment on extended surfaces. Both natural convection and the forced convection, those experiments they can be performed on this setup. Coming to the next setup, this is related to radiation heat transfer. So here the laws related to radiation heat transfer, Stephen Boltzmann law and other associated laws, they can be verified, and the student they can know that how the radiation heat transfer that takes place. So the related to boiling and condensation, these setup they can be used, and the student they can perform the experiments on this one. Now this is also related to, now you can say, convection heat transfer, where the student they can perform the experiment on heat exchangers.
Welcome to the refrigeration and air conditioning lab. This lab is in the 8th semester of mechanical engineering department, and in this lab the students perform experiment on various types of refrigerant systems and air conditioning systems. This is a cascade refrigerant system. It produces a very good temperature. The performance of the air conditioning system under various conditions like the varying humidity of the air, varying temperature can be performed. So students perform the experiment, and this setup all the data are stored in the computer itself. So there is a prototype of cold storage system. So inside it the cold is produced, and this space is used for storing the food materials or the fruits. See the rotary compressors or semi-sealed compressors or the hermetic compressors. These all type of compressors are used in the refrigeration systems. And another kind of refrigeration system which is called the vapor absorption system. This is a noiseless system, and then we have this this unit where all the components used in the refrigeration systems are displayed. These are also the various components used to create the network of the system.
Welcome students. In this hall we have two labs. One is solid mechanics and other is mechanics of machine. Basically these labs are associated with the testing of materials and various drive mechanisms. We have this tensile testing machine on which we test the various materials for its strength, tensile strength, compression strength, etc. Then we have these impact testers on which the impact strength of the various specimens are tested. This is a torsion testing machine in which the torque loads are applied and shear strength of the materials are evaluated. It is a very important features for any new material. We need Young's modulus and other material properties which are calculated in this lab. The mechanics of machines lab basically deals with various driving mechanisms. So here we introduce to our students with the mechanisms such as 4-bar mechanism, inversion of double slider crank, single slider crank mechanisms. These driving mechanisms completely demonstrate all types of mechanisms to the students, and the students also perform various activities to build their own mechanisms here. In this experiment we have a non-destructive torsion test wherein we do not break the specimen but we test the material for its shear strength. This experiment we have to evaluate the deflections of beam. We can vary the lengths of the beams as well as the cross section and calculate the maximum deflection of any beam subjected to the various types of loading conditions. Here we have certain demonstrations which are made by the students as a part of their project work.
So welcome to this automobile engineering lab. So in this lab we have all the latest technologies related to automobile engineering. So like here we have automatic transmission system. So this is planetary gear system. This is your talk converter, very latest technology is available in the lab. So this is hydraulic gear change mechanism of Audi A4. This is dual shift gearbox of Audi A4 and is also used in Volkswagen Jetta. So differential and other gearbox technologies. Our petrol engine. We have also braking systems, all the clutch drives, suspension systems, then your crankshafts, propeller shafts, slip joints, and definitely the axles. Right, so these are your synchronous transmission system, steering system, and the engines. We have very traditional engines in this lab. Then differential cut section, your synchronized transmission system assembly, the chassis. Right. So this lab is equipped with all the major equipments and the latest technologies available in the market. So we give a wide range of exposure to the student, traditional as well as the latest one. Thank you.
Okay, I welcome you to the Laboratory for Particle and Bulk Solids Technologies. This is mainly a research laboratory, but research has become a fundamental part of a lot of industrial problem solving. So students, they come here for internship, they do their thesis. At the PG level, undergrad students, they find the internship route quite interesting. They get exposed to developing new processes, new technologies, new products. This is our latest lab, developed 2-3 years ago. This is entirely funded by NTPC, a very prestigious organization. So students here, they work on the PLC, they work on these big machines, they work on pneumatically operated valves. So they get a very good feel of interdisciplinary approach of engineering, mechanical, electrical, instrumentation, data acquisition, and so on. So the advantage is when the students actually graduate and they go to industry, so they have already seen these kind of systems, because in the industry is always interdisciplinary. So they have been already exposed to providing industry type solutions.
So when they go, they are already well familiar and they are already well trained. So they do a very good job, our students, when they go to industry.
Dynamics and vibration lab. This lab is related to the experiment for the mechanical engineering vibration. Using this bifilar apparatus, we can find the moment of inertia of any arbitrary shaped body. This is a very simple spring mass system, and if we will give some excitation to this system, we will be able to measure the natural frequency of this system. You can see that this is a beam connected with a spring, and there is a motor connected here. So if I will give rotation to this motor, the motor will give some harmonic force excitation to this beam, and we will be able to find the natural frequency as well as the displacement of the system. The next one is the whirling of shaft apparatus. Here we are having a shaft connected with a motor, and there is a disc connected here. So if I will give rotation to this shaft, there will be some vibration, and this apparatus is actually related to the industrial application. In many industrial application where you have to run some shaft, you have vibration, and that can be visualized using this apparatus. Thank you.
Welcome to the mechatronics lab, and this lab is used for basically UG and PG studies. And these are 8051 microcontroller, and this is used for the experimentation of the 4th semester UG students. And some small robotic arm and gripper is there. And this is the DC motor speed control of the DC motor. And this is flexible robot. This is basically the snake robot. And this is hybrid manipulator. And this is one type of robot, and this is 4-axis robot. And this is based on parallel mechanism, and this is used for manipulating or for pick and place operation of different objects. This is the 3-link and 2 flexible links are there. And this is a very big project of Department of Science and Technology, DST. Amount of 64 lakhs, and we have collaboration with IIT Delhi for this project. And we have fabricated this flexible link for motion, and we will use this for vibration suppression technique.
Welcome. This is Internal Combustion Engines Laboratory of Mechanical Engineering Department. It caters to undergraduate mechanical engineering students, production, mechatronics, as well as ME thermal students. We have a lot of infrastructure out here in the field of internal combustion engines. This is a variable compression ratio engine which runs both on diesel as well as petrol. All you need to do is change the head of the engine. This is a variable compression ratio engine running on diesel engine. It can also run in alternative fuels. Many students have done research on alternative fuels, particularly biodiesels, in this engine. This is a common rail direct injection engine. We carry out a test by the name of Moore's test on it. We can plot the torque variations in this engine. We also have the apparatus which can help us in analyzing the engine performance, emissions, as well as your fuel consumption, torque variation. You can easily control and study those parameters and effect of emission analysis as well. Donated by BMW. It is a 3 series engine. It is a 4-cylinder, 2-liter engine.
Into lab and operational machining lab. Okay, let's visit of these. So here it is the electric charge machining center. It is used by PG students for their coursework, and they are doing their digitation work on it. And then this is the ultrasonic machine. This is used by PG students as well as UG students. And students, they are doing their digitation work on this equipment. So this lab is very useful for UG and PG students of both mechanical and productions.
So this is the venue of the machine tool lab. Here the different facilities of the different machines are there. So these machineries are basically used for giving the exposure or giving the values to our UG students. This is radial drilling machine, right? This is basically the simple lathe. Here this is the shaper machines. We are having the drilling machine also. We are having the grinding machines. So these different facilities are there. Along with we are having the piezoelectric dynamometer. So that dynamometer is basically helping us to measure the different cutting forces during the machining process. And apart that, basically for UG curriculum, these facilities are also used to basically utilized by the students of the different team, like the Team Fateh. So this is the space or the venue of the Team Fateh, where students are utilizing our resources and they are conducting the different experiments as per their need.
Are there. So in all the evaluations they have scored good marks. And there is another car which is designed by our team Ultron. So this car basically they are designing for competition which is done on the uneven surface. Okay, so they are basically targeting on the national competitions. They are not going for international. They are going for national only. But Team Fateh, if you see, they are going for national as well as international.
Metrology and Industrial Engineering Lab, please come. And mainly this lab will focuses on mainly BTech, MTech and research purpose. And one such we are having a high-end machine here. It is a surface roughness meter, which is used for calibrating the roughness for these various different types of processes. To calibrate the angle measurement, height and everything, to calibrate. So we have a different set of equipments here. Please come. These are the different equipments, and one such here it is a profiler projector, and here we are going to use the what is the angle, cross section and everything. We are doing calibration here. Along with that, we are having another type of equipment which is used in the height gauge meter, which we are going to use for checking this height and calibrating everything.
Welcome everybody. This is the rapid prototyping lab. So this rapid prototyping lab is virtually utilized for UG as well as PG courses, and even PhD scholars are also using this lab. Now for PG CAD/CAM and PG production, this lab is utilized, and for UG production engineering as well as for PE mechanical engineering, this lab is going to be utilized also. Over here, these are the wire-based 3D printers which are available, and we also have one FDM printer purchased from a FIS project, and that is also available in the lab, which we have in our institute. And this technology is completely different from the 3D printing technology, and in this printer we can prepare parts of any complexity without any hindrance.
Welcome to Experiential Learning Center, and we have this as a central facility where we introduce to the students various industrial grade equipment, and the mandate is we make the student aware of all the technologies by making use of hands-on experience on industrial grade equipment and a guided tour through all these technologies. And then students also take part in some projects. They explore the self-learning and they also create some projects for societal needs and definitely work on industrial grade equipment. You can see there are some equipment which are plate type heat exchanger developed by students. They check it for various parameters, design it themselves, and then there are some discussions which they make and they learn from each other. So these are the test rigs which are designed in the campus itself. So students make use of these test rigs, and all these activities the students participate. They are done before or maybe part of some course, so that they get a better insight in their courses. We have 30 number of Honda GX160 engine, which students they open it, disassemble and assemble it, and they run these engines themselves. They look into all technologies and all mechanical engineering through this in their second year. 30 number of gearboxes which are from Maruti Udyog. So we give the students internal complete know-how about the elements of this. In the same line we have developed 10 number of chair testing machines in house. So these are the devices, these are the industrial grade equipment which is developed in house, designed by faculty members but developed by the students who participated in some summer activities. And these are all fully functional industrial grade machines to test the durability of the chairs. So as a fourth semester activity, we have these equipment which is a 2-axis CNC table. So we can see the entire setup here. We have got the controller, the drivers. These are all industrial grade. The industrial grade system, which is like how the cabinet and the panel should look like. And then we have this table which is custom designed for the students to learn that what are the different elements of a CNC machine tool. The students will open this up, they will close it back, and they will also program it, and they will write their own programs and algorithms so that they can also develop machine tools, develop the softwares, develop the control systems, and they can also pick up from the list of n number of available off-the-shelf parts for development of these technologies, for 3D printing, for metal cutting, and so forth.